Welcome to the Deep Dive. Today, we're tackling, well, a really crucial topic.
Yeah, definitely.
The world of DevOps. It moves so fast, right?
Right.
We're going to look at the key trends shaping things as we head into 2025.
Mm-hmm.
We've gone through a pretty detailed analysis, and our goal here is to pull out the really vital shifts, the stuff you actually need to know to stay ahead.
Absolutely. Because, let's face it, keeping up with software development, deployment, it can feel pretty overwhelming sometimes.
It really can.
So yeah, we want to bring some clarity today, highlight what's genuinely significant for, developers, DevOps engineers, CTOs, basically anyone involved.
Exactly. Think of this as your guide to understanding the big transformations coming up. We're talking about AI getting really baked into automation.
Good one.
How infrastructure management is changing, this push towards like fully automated operations.
Yeah, MOPS territory.
Yeah. And security getting integrated right from the start, advancements in containers, making life easier for developers.
Developer experience, yeah.
Keeping an eye on costs, which is huge now, and, what's next for CI/CD. So let's just dive right in.
Sounds good. Let's start with AI and machine learning in DevOps, because it's not like some future thing anymore. It's really becoming part of the fabric of how we build and run software.
Right. It feels like it's moving beyond just, making things a bit quicker. How's really changing the game?
Well, the analysis really points to a deep integration. It's weaving through the entire DevOps workflow. And the impact is, well, pretty significant gains in automation, efficiency, and maybe most importantly, security.
Okay.
Like, for example, AI algorithms are now analyzing CI/CD pipelines. They're learning from past deployments to predict where things might fail.
Wow.
And even automatically tweak configurations to lower those risks.
So it's shifting from just reacting to problems to actually getting ahead of them.
Exactly. It's proactive. Think about anomaly detection, right?
Yeah.
AI figures out what normal looks like for your system.
Establishes a baseline.
Precisely. And then it flags anything weird, anything that deviates, which could signal trouble brewing, lets you jump in early. And then if something does go wrong, AI-powered auto-remediation can often figure out the cause and fix it automatically.
Usually, without someone having to manually troubleshoot.
Often, yeah. Minimizes downtime, less manual firefighting. It's pretty impressive how AI is learning the complexities of these systems.
Can you give us maybe a couple of concrete examples? How does this look in practice?
Sure. So imagine an AI churning through years of deployment logs.
Okay.
It finds these really subtle patterns that historically came right before a failure.
Things a human might miss.
Totally. So now the team can address those underlying issues before they cause an outage. Or on the dev side, you've got tools like GitHub Copilot.
Heard a lot about that.
Yeah, using AI to help write code, suggest completions, even nudge you towards best practices while you're typing.
Like pair programming with an AI.
Kind of, yeah. And for infrastructure, you have AI ops platforms like AWS, AI DevOps Guru. They're proactively spotting and often fixing infrastructure glitches before users even notice.
It really does sound like having this super smart assistant watching over every stage. What are some of the key tools mentioned in the analysis that are really pushing this?
Well, GitHub Copilot is definitely one for the coding side. AWS AI DevOps Guru for the infrastructure insights. And Dynatrace also gets highlighted for its AI-driven monitoring and observability. It gives you really intelligent insights into performance.
Okay, interesting. Let's shift gears a bit. GitOps and Infrastructure as Code, or IAC. These aren't exactly brand new concepts.
No, they've been around.
But it feels like their importance is really ramping up now.
You're absolutely right. GitOps is, it's becoming a cornerstone for managing infrastructure effectively.
Right.
The whole idea of using Git, your version control system, as the single source of truth for your infrastructure config, it just unlocks a whole lot of benefits. Think of it like managing your servers the same way you manage your code.
Okay, and what are those main advantages? Consistency.
Consistency is massive, yeah. And repeatability. Because your entire infrastructure is defined right there in Git, every single deployment you make from that configuration is going to be identical.
So less chance of configuration drift or those it works on my machine problems.
Exactly. It really cuts down on that. And crucially, GitOps makes automated rollbacks really straightforward.
Oh.
If a deployment causes issues, you just revert to a previous commit in Git, and boom, your infrastructure automatically rolls back to that known good state.
That's powerful.
It is. And it leads to faster, much more secure deployment pipelines because every change is tracked, it's auditable, and you can reverse it easily.
Makes total sense. And IAC infrastructure as code, That feels like the underpinning that makes GitOps work so well, right? How is IEC evolving?
Yeah, IEC is definitely the foundation, and it's maturing fast. The tools are getting more powerful, more flexible.
Like Terraform.
Terraform is still a huge player, yeah. Great for handling infrastructure across different clouds using that declarative style. Then you've got Pulumi.
Heard of that one too.
Which lets you define infrastructure using actual programming languages like Python or TypeScript. That's really appealing to a lot of developers.
Use the language you already know.
Exactly. And then there's Crossplane, which is interesting because it's designed to manage infrastructure resources right from within Kubernetes itself. Very cloud-native approach.
So it's all about managing infrastructure with the same kind of rigor and control we use for application code. Okay, now, the analysis brought up NoOps and hyper-automation. That sounds ambitious, like the next level of automation.
It definitely is ambitious, yeah. NoOps is sort of the end goal vision, fully automated IT operations with ideally very little human intervention needed day to day.
How is that even possible?
Well, it's becoming more achievable thanks to a few things. Serverless computing is a big one. AWS Lambda, Azure Functions.
But the cloud provider handles the servers.
Right. You just focus on the code. Plus, you have AI-driven infrastructure that can heal itself and Kubernetes clusters that are getting better at self-managing.
So the systems themselves are becoming smarter, more autonomous.
That's the direction, yeah. And hyper-automation is kind of the engine driving us there. It's not just one technology. It's strategically combining AI, machine learning, maybe even some RPA, robotic process automation.
Okay.
And applying them all within the DevOps context. And the key thing here is it's not just automating simple, repetitive tasks anymore.
Right.
It's about automating entire complex workflows, even some decision-making.
So what does that mean practically for DevOps teams? What are the real benefits?
Well, potentially, it could massively reduce the manual grunt work for DevOps engineers.
Freeing them up for other things.
Exactly. More strategic work. It promises much faster troubleshooting, often automated fixes for incidents. And by automating things like security checks or infrastructure provisioning, it should boost overall security and reliability, especially in the cloud.
Speaking of security, that's always top of mind. The analysis really hammers home the importance of DevSecOps for 2025. Why is embedding security so deeply becoming even more critical now?
Well, you just have to look at the headlines, right? Cyber threats are getting more sophisticated, more frequent.
It's constant.
Treating security as something you bolt on at the end, it just doesn't cut it anymore. It's too risky, too slow. DevSecOps tackles this head on by making security everyone's responsibility, integrating it right into every single phase of development.
In the very beginning.
From design through coding, testing, deployment, and even into operations. It's a cultural shift as much as a technical one.
So what are the key advantages then of doing it this way?
A big one is automating security testing. You can build things like SAS static analysis, looking at the code itself.
Okay.
DAS dynamic analysis, testing the running application, and even RASP, which offers runtime protection. You can build all that directly into your CI/CD pipelines.
So you catch things earlier.
Much earlier, when they're cheaper and easier to fix. The analysis also points to the rise of zero-trust architecture.
Never trust, always verify.
Exactly, that principle applied everywhere, inside and outside your network. And with software supply chains getting so complex, all the third-party libraries we use, securing that supply chain is becoming absolutely paramount.
So that shift-left idea for security is really central.
Yeah.
What are some specific practices or tools that are essential here for DevSecOps?
Yeah, shift left is the mantra. Using SBOM's software bill of materials is becoming critical.
Right, knowing exactly what's in your software.
Exactly. A detailed inventory of all components, especially open source dependencies, so you can track vulnerabilities. And since containers are everywhere, robust container security standing both before deployment and during runtime is non-negotiable.
Got it. Any key tools mentioned?
Yeah, the analysis highlights SNCC for its broad automated scanning code, dependencies, containers. Aqua Security is mentioned as a specialist in container security, and check marks for really deep static code analysis.
Okay, let's talk Kubernetes. It's been the king of container orchestration for a while now. How's it continuing to evolve in the DevOps world for 2025?
Yeah, Kubernetes isn't going anywhere. It's still the dominant platform, but the ecosystem around it is definitely not standing still. It's constantly innovating.
Right.
We're seeing some key trends that are making it even more powerful and sometimes simpler to manage.
Oh, like what kind of trends?
Well, Kubernetes operators are becoming really widespread.
Operators. Okay.
Think of them as like automated SREs for specific applications. They know how to run complex stateful things like databases or message queues on Kubernetes, handling tasks like backups, upgrades, failover automatically.
So they encode the operational knowledge.
Exactly. Knative is also gaining steam for building serverless-style applications on top of Kubernetes, makes that developer experience a bit smoother. And for observability, OpenTelemetry is really emerging as the standard.
Right, for collecting metrics, traces, logs.
Yeah, a unified way to get telemetry data from your Kubernetes clusters and the apps running inside them. Super important for understanding what's going on.
The analysis also mentioned edge computing. How does that fit into this DevOps puzzle?
Edge computing. Yeah, that's interesting. Bringing compute power closer to where the data is actually generated.
Right, out at the edge of the network.
Exactly. This has big implications for DevOps, especially for apps needing super low latency or real-time processing. Think about like 5G applications or AI doing analytics on IoT sensor data out in the field, or even distributed cloud setups.
Okay.
It forces DevOps teams to ask, how do we manage deployments, updates, monitoring across all these potentially hundreds or thousands of distributed edge locations? It's a different challenge.
Yeah, definitely adds complexity. Now, something that sounds aimed squarely at making developers' lives better. Platform engineering.
Yes. This is a really hot topic right now. Platform engineering is all about building and running internal self-service platforms.
Internal platforms.
Yeah, platforms built by an organization for its own developers. The main goal is to seriously boost developer productivity and just streamline the whole software delivery process.
How does it do that? What does it look like day to day for a developer?
It tries to abstract away a lot of the underlying complexity of infrastructure and tooling. A key piece is often an internal developer portal, or IDP.
IDP, okay.
Think of it as a central hub, like a web portal, where developers can go to get everything they need.
Self-service style.
Exactly.
Yeah.
Self-service. They can find automated workflows for building and deploying their apps, use standardized templates to ensure consistency, even provision their own infrastructure resources like databases or queues without needing to file a ticket and wait for an operations team.
So it removes bottlenecks.
That's the idea. Empowering developers, giving them the tools they need when they need them in a standardized, easy-to-use way.
Sounds like it could genuinely speed things up and reduce friction. Are there specific tools or platforms driving this?
Yeah, several are mentioned. Atmosley is positioning itself as a comprehensive self-service platform. Backstage, which came out of Spotify and is open source, is super popular for building customizable IDPs.
Right, Backstage.
Humanitech focuses specifically on providing a kind of underlying platform for building these internal platforms, very cloud native. And Cortex offers tools around service catalogs and platform management to improve visibility.
Okay, lots happening there. Let's pivot slightly to the money side of things. FinOps and cost optimization seem to be getting a lot more attention. Why this growing focus on cloud costs within DevOps?
Well, it's pretty simple, really. As companies move more and more workloads to the cloud, those bills can get really big, really fast.
Yeah, I bet. Cloud spend can spiral.
It absolutely can.
Yeah.
So FinOps, which stands for financial operations, is this merging discipline, really a cultural practice, trying to bring financial accountability to the cloud.
So it's not just about cutting costs, but understanding them.
Exactly. It's about enabling teams, including engineering and DevOps, to make smart decisions about cost, but without slowing down innovation or hurting quality. It's about visibility and accountability.
Makes sense.
Yeah.
What are some of the key strategies or practices involved in FinOps?
It really starts with getting clear visibility into where the money is going, often using specialized tools, sometimes AI-powered, to analyze spending patterns and pinpoint optimization opportunities.
Okay.
Things like cost forecasting and budgeting are also crucial for planning. And then there's implementing automated scaling, making sure you're only paying for resources you actually need, scaling down automatically when demand is low.
Right-sizing resources.
Precisely. Continuous cost optimization, basically.
Are there specific tools recommended in the analysis to help teams with this?
Yeah, a few stand out. KubeCost gets a mention specifically for tracking and managing the costs associated with Kubernetes clusters, which can be tricky.
Oh, yeah.
AWS Cost Explorer is a standard for understanding your AWS bill in detail. And tools like Spot.io focus on automating cost savings, often by intelligently using cheaper Spot instances from cloud providers.
Got it. Okay, last main topic. The future of CI/CD. Continuous integration, continuous delivery. They're pillars of modern DevOps, but they're still evolving too.
Oh, definitely. CI/CD pipelines aren't static. They're getting smarter, faster, more adaptable.
How so?
We're seeing a move towards more event-driven pipelines. Instead of just running on a schedule or a code commit, they can trigger based on all sorts of events happening in your system.
Making them more responsive?
Yeah, potentially faster and reducing delays. Progressive delivery techniques are also becoming much more common.
Like blue-green deployments, canary releases.
Exactly. Rolling out changes gradually to a small subset of users first, monitoring closely, and rolling back quickly if needed. It's about reducing the risk of big bang deployments.
Makes sense.
And as we touched on earlier, AI is creeping into deployment monitoring too, providing smarter insights into whether a new release is healthy, predicting potential issues based on subtle signals.
Constantly learning. And what about the tools themselves? Any key CI/CD tools organizations should be looking at for 2025?
For teams all in on Kubernetes, Argo CD is really popular. It's a GitOps-style continuous delivery tool, ensures your cluster state matches what's in Git.
Okay, aligns with the GitOps trend.
Totally. Jenkins X is another one, designed specifically as a cloud-native CI/CD platform for Kubernetes. And of course, GitHub Actions is huge.
Yeah, integrated right into GitHub.
Right, super convenient, very flexible workflow automation. Lots of teams are standardizing on it.
Okay, wow. So if we try and wrap this all up, it really feels like the DevOps landscape in 2025 is being powerfully reshaped. You've got AI driving automation everywhere.
Big time.
This absolute necessity of baking security in from the start with DevSecOps.
Crucial.
Cloud native tech like Kubernetes, maturing but also expanding with things like operators and edge. A real focus on making developers more productive via platform engineering.
Yep. Developer enablement.
And this critical need to get a handle on cloud costs with FinOps. It's a lot.
It is a lot, but it paints a clear picture. The organizations that really lean into these trends, that adopt these innovations proactively, they're the ones who are going to be more efficient, more secure, and able to scale effectively.
Right. They'll be better positioned to succeed.
Definitely. It's about building that future-proof capability.
This has been incredibly insightful, really unpacking these key shifts. So thinking about everything we've covered today, AI, DevSecOps, Kubernetes evolution, platform engineering, FinOps, it leads to a final thought for you, the listener.
Yeah.
Considering all these significant trends, what's maybe the one specific area of DevOps that your organization should really prioritize exploring or maybe investing in over the next year? What's going to give you the biggest boost towards future-proofing how you develop and deliver software?
That's a great question to ponder.
Maybe take some time, dig a bit deeper into the tools or concepts we talked about that really resonated with your situation. Thanks so much for joining us for this deep dive.